This video will demonstrate how to create an efficient document processing system by implementing nested workflows in Azure Logic Apps. The Desk Connect desktop automation driver will also be leveraged as the catalyst for this system. To begin, I will create two new Azure workflows. The first workflow I add will be the child flow, which will ultimately be nested within the parent workflow. For now, I will just add an HTTP request action as well as a response action to this flow. Note that all child flows require a response action, as this enables the child flow to be invoked in the parent flow. Next, I will add the parent workflow, which I will call the primary flow. I will add an HTTP request action to the flow. I will also initialize a variable to represent the document type of the input file. To do this, I will utilize the trigger outputs function, which extracts the identified document type variable from the body of the HTTP request input. Please note that the body of the HTTP request is retrieved directly from a desktop automation driver submission and contains all relevant information from the submitted file, including the file attachment, file name variable, data, and document type. I will now add a switch action to the flow. The switch action acts as a control flow statement that allows users to conditionally execute other actions based on the value of an expression. In this example, I will use the document type as the value that each case depends on. I will then add a case to the switch action that will be executed when the document type is a patient registration form. I will add the Invoke a workflow in this workflow app action to this case, and then select the child workflow I created earlier as the parameter. I will also add a new body parameter to the action and configure it with the dynamic content body from the HTTP request. This will send the information received by the parent flow from the desktop automation driver to the desired child flow. When I hit save, the parent flow's HTTP URL is generated. I will copy and paste this URL into my desktop automation driver workflow. I can then hit test output to generate a JSON file that contains all of the variables that will be sent to the Logic Apps flow. Note that this JSON data can be accessed in the preview pane, as well as in a text file sent to the Documents folder. I will copy the JSON text and then open my child Azure flow. Since the data being sent from the desktop automation driver is in JSON format, I will add the parse JSON action to the flow. This action will extract all of the key variables from the input JSON data. The HTTP request body will be used as the content parameter. Then, I will paste the JSON from the desktop automation driver test output into the parse JSON action sample payload, which will generate a functional JSON schema. I can now use the parse JSON data to populate variables. I will begin by adding an initialize variable action to the flow. I will set the variable type to string and assign the variable a name. In this case, it will be attachment. Then, I can select my desired dynamic content from the parse JSON action, which for this variable is the body attachment. Populating variables using the parse JSON data is quick and easy, which is the significant advantage of using the parse JSON action in a flow. I have now created all of my desired variables for this workflow. The final step I will add to the flow is the send an Outlook email action. There are many parameters to configure, beginning with the email recipient. In certain cases, dynamic email variables can be utilized to automatically update the recipient with each submission. For this example, though, I will just use a static email that can be monitored for the video. I will create an email subject using some of the dynamic content variables from the flow. I will also implement these variables in the email body. Utilizing flow variables in this manner simplifies and streamlines the entire email creation process. Once the email body is created, I will add a new attachments parameter to the action. I will then configure the attachment parameter using the dynamic content variables for the file name and file attachment. Note that a code view can be viewed for every action, which can be useful to ensure that each action is configured as desired. My Azure flow is now completely configured, so I will hit save. I will also finish my desktop automation driver workflow configuration, which will send the data from the input document to the parent Azure flow. The parent flow will then invoke the child flow, and the output email will be sent. The email contains both key information extracted from the document as well as the file attachment itself. Any document of the same type can now be efficiently processed in the same way. One important thing to note is that each document submission's run history can be accessed in the Azure Workflows Overview pane. Each run history provides valuable insights into the inputs and outputs of each step of the flow, which can be extremely helpful when troubleshooting any submission errors. Moving forward, I will now add more cases to my switch action in the parent Azure workflow. Given the simplicity of this process, numerous cases can be effortlessly created to handle various document types. In addition to this, I can configure the default case with its own child flow so that even unidentified documents still get processed by this system. This will ensure that every document that is sent to the parent flow will be correctly processed. Furthermore, new cases can be continuously added as needed to further increase the usefulness of the system. Thus, implementing nested Azure flows in conjunction with the Desk Connect desktop automation driver establishes a highly efficient and adaptable document processing system.